Yeah.
Hello, everybody. I hope you can hear me now. I'm looking at someone to confirm that.
That's right.
No chats yet. No answers.
Yes.
So they can hear me?
Yeah.
Okay, welcome everybody for a second time. As I was saying, what you didn't hear is welcome to the first evening with the first lecture for Bite of Science 2021, the Belgian edition. We're going to have 6 talks for you today and the coming 2 days. I should probably also explain where we are this evening. We're at the Public Observatory Armand Pien. That's why you see very cool stuff in the background, like a rocket. Soon I will move out of the way, then you can have a better look at the rocket. And the reason why we are here is that the Public Observatory Armand Pien, they kindly allowed us to record and broadcast here tonight in this great setting. For those of you who are not Belgian, I might explain who Armand Pien is. The Belgians will probably know it, or at least the Flemish people will, because he presented the Flemish TV weather for several decades. And the reason he has a public observatory named after him is because he was always a proponent of amateur astronomy and meteorology. So he really encouraged the public to also participate and do their own findings to assist the academics. And that's why they named this public observatory after him. So we're very grateful that we can be here this evening. And we're going to have two talks. I'm going to introduce you to the first speaker in a second. But both talks have one thing in common, is that both of them, it's very ironic in this pandemic, but both of them might mean we will be destroyed. Either we will be destroyed by the universe, or we will be destroyed by the results of fake news if the pandemic doesn't kill us. And for the universe, our first speaker is going to cover that. I will introduce to you Lenka Zikova. Welcome.
Hello.
Hello. And you are going to talk to us about how the universe might or might not destroy us.
Yes.
But before we start with that, could you please explain us how did you become, because you're a scientist, you studied the universe, how did you become interested in studying the universe?
Oh, yeah, I did. Well, it started already when I was a little girl. I really remember the particular moment I was sitting in a garden with my uncle and my nephew, and we were observing the stars. And of course, it was night already, and I was giving so many questions to my uncle, and he was trying to answer all of them. And at one point, he stopped answering. So I started to figure out the answers by myself. And after, I don't know, 5th, 6th question, when I really started to think, I also realized that my uncle fell asleep. And that was the reason why he didn't answer to me. But I remember that moment when I had to start to think about the answers, that was the moment where I started to be interested.
Wow, that's great. So in the tradition of Armand Pien, you also started as an amateur scientist, and look at where you are today on the stage of Bite of Science.
Thank you.
Well, I will make space for the rocket and for you. So enjoy this talk and good luck.
Thank you very much. Hi, everyone. I'm very excited to be here, and thank you so much for having me here at Bite of Science. I am really kind of excited to share with you my passion of destroying the humanity by various cataclysmic events coming from the universe. And before we look at the science behind all the possibilities I have here for you, let's look at the past. Was there any time when such horrifying event ever happened? Well, currently we have around 9 million animal species on the Earth, while in the whole history of life on Earth, there were about 5 billion animal species. So it means that 99% of all the animal species went extinct. So indeed, there is some kind of extinction. It's never like that you have several events of extinction and there's nothing in between. There's constantly some kind of background of extinction. But indeed, we have at least, so far as we know, five mass extinctions that they happen. Some I'm going to tell you two different stories. First story will start those 66 million years ago, and it will start over here at the map, where you see Yucatan Peninsula. And this is the event when the dinosaurs went extinct. Back then, an asteroid that was pretty wide, about 10 to 30 kilometers in diameter, entered the Earth's atmosphere in the speed of 10 to 20 kilometers per second. It's a huge speed. So, by the way, most of the time when I'm going to speak about speed in this lecture is in kilometers per second. Not sound is off again.
I'm back.
It's back. Perfect. I was wondering if I should make the asteroid with my body to hit this.
Yes.
Well, perfect. I don't have to do it. So we're back. So 66 million years ago, what happened was that this huge asteroid hit the Earth atmosphere with this amazing speed of 10 to 20 kilometers per second. I'm saying amazing speed. It is truly huge. It's like you going through hands in 1 second. It's truly amazing for us people. However, what you're going to see later on, this is on the lower range of the speeds I'm going to talk about later in this presentation. So what happened was that this asteroid hit the Earth, exploded with energy of billion of Hiroshima bombs. This swept away everything living in a range of 1,000 kilometers. And what was worse was that all the debris that was thrown out in the air was falling back as a secondary or as a shower of secondary impactors. So therefore, the impacted area was way bigger. Earthquakes, tsunamis happened because the asteroid hit partly the water. This was all very bad. However, this impact by itself would not lead to extinction of dinosaurs. Mostly the effects that happen afterwards caused this, because the asteroid planned its mission ideally in an area that is rich in carbonated rocks that are rich in sulfur, and plenty of these elements were evaporated into the atmosphere, and later they rained down in the form of acid rains. Also, some of the elements went into the sea and caused change in salinity, that is a level of salt or other minerals in the sea, that caused marine fauna to extinct. Also, the dust in the atmosphere formed a layer that was impenetrable for the light, and it actually decreased the light coming to the surface of the Earth, meaning that all the organisms, plants, or anything else, bacteria that are dependent on photosynthesis, died out, and therefore the base of the food chain was the cause that later on also other animal species could extinct. So this is one story. Do we have any proof? Yes, we do some proofs. There is this famous iridium layer. It's a layer of element that is called iridium. Iridium is very rare in Earth crust, but it's pretty abundant in meteorites. And this layer was lying exactly at the boundary of two eras when the extinction of dinosaurs happened. Also, we have found the crater after this impact. It's called Chicxulub, and it's about 180 kilometers wide. You can see it on the geological map in the presentation. So that's the first story, very nasty story. We have another one over here, and it involves somebody called Anne Hodges, who lived in Alabama. Now, we are not in 66 million years ago, of course. There was no Anne Hodges back then, but we are now in the year 1954. And what happened was that Anne Hodges was resting on her couch in her living room when suddenly a meteorite hit her. Indeed, 5-kilogram meteorite hit the roof of her house, went through, bounced off the commode, and hit her in her head. I have here some photos from the time, as you can see in the presentation. So you see that she suffered with a really huge bruise on her hip. On the photo on the right side, you can see her with her husband. They're both pretty happy because probably then they realized that they can earn some money from the meteorite. Unfortunately, they were renting the house, and the lady said that the meteorite fell on her property and that she's going to sell the meteorite. However, they went to some trials, and at the end they could keep the meteorite. And they tried to sell it, but nobody bid that high as they wanted. So at the end, they donated the meteorite to a museum. So this is the second story. You see that they are very much different, and the difference is mostly because of the size of the asteroid and of the meteorite that impacted those two areas. Now the question is, can this happen again? For that, we have to look at a few pictures like this. Good news is that the asteroids that are so massive, so big that they can destroy the humanity or the life on Earth, they are really not that much abundant. There are few of them. However, those that are much smaller, there are many of them. It's pretty similar to when you have a biscuit in your hand, like speculoos, Belgium, and you crush it, you will have just a little bit of the big chunks, but you're going to have a lot of this dust, speculoos particles. So similar distribution we see also in the universe. So we have not that many of the big asteroids, while we have a lot of the small ones. The big ones are pretty well mapped, well, because they are better to be seen, right? So scientists did map most of them. However, the smaller ones are not yet that well mapped, but they still can cause a lot of troubles. It also depends on the probability that something like that will hit us. So, for example, such a huge asteroid as made dinosaurs extinct comes once in 100 million years. So don't worry. Something smaller can come much sooner, once in 100 years. For example, an asteroid that can erase a town from a map, that can come every 1,000 years. But don't be scared. These numbers are truly just illustrational, because most of the meteoroids that enter the Earth atmosphere can fragment into smaller pieces, and they don't cause so much problems. Also, they can fall into water. So don't be worried. Also, you cannot take these numbers as specific or particular, meaning that if such a huge asteroid fell here 66 million years ago, and it should fall here every 100 million years ago, that you have 34 million years ago to wait for another one. It doesn't work like that. Okay, so it's just a roughly probability, but it can come sooner or later. And it also very much depends on the material of the asteroid. It's a big difference if the asteroid is a porous rock or if it's rich in iron. The effects from these asteroids are very, very much different. It depends on the speed, on the angle it enters the atmosphere, and so on. But now I would like to get you, if you're watching this, hopefully, getting more interactive with me, because I would like you to vote where this lecture is going to go. I have for you a poll, so please, on your devices, if you can either scan the QR code, or you can go to wooklab.com/pintofscience, and there's a question for you. Would you like to, right now, before I move to a big topic, hear more stories when asteroids or some meteorites fell down? Or are you interested in knowing and discussing the possibilities when an asteroid would hit Belgium? So let me know, you have some time to vote. So in the first case, I will discuss Chelyabinsk and Tunguska event, while in the second case, I have prepared some calculations of two asteroids hitting either Ghent or Brussels, and calculating what would be the effects. So I hope people are voting. Yes, good. Let's have a few seconds more. Okay, let's take a few more seconds. And okay, we are stopping the voting, and the result is number 2, right?
For sure. Yes.
Okay, perfect.
90%.
90%, of course, Belgians. I know you would like to see Belgium a bit more flatter than it is already, right? Yes, but don't worry, there would be some hole as well. So let's see. I have here for you 2 cases. In both cases, the asteroid is 1 kilometer wide. But in first case, the asteroid is entering with a speed of only 11 kilometers per second. It gets under the angle of 10 degrees, so very, very flat one. And it's made out of porous rock. And it's going to hit Brussels. I was very kind to Brussels, as you're going to see in a bit. Because what is going to happen? Such an asteroid, although 1 kilometer wide, because it's made out of porous rock and entering in a shallow angle, it would fragment. It would create a lot of little fragments that would fall in Belgium in an ellipse you can see in the presentation. So there would be some chunks of the asteroid falling down. Those biggest would create a crater that would be about 5 kilometers wide and a nearly half a kilometer deep, the final crater. What would happen would be, meanwhile, in Ghent, that in about 2 minutes, there would be a splash of ejected material. The maximum thickness would be around 2 centimeters, so there would be some pebbles falling down over here. There would be also an air blast. Maximum wind speed would get into 180 meters per second. That's pretty rapid. There would be an earthquake, so some buildings might collapse, and there would be definitely some kind of damage. There would be also a big sound wave coming in with 101 decibels. That's like you would be standing next to really loud motorcycle. So your hearing might be damaged. It might be hurtful as well. So this is what would happen in Ghent. If you're in Brussels, then you are doomed, of course. And however, this event would happen every 230,000 years. Of course, I don't mean entering or hitting directly Belgium. That's in general hitting Earth, this kind of asteroid. Anyway, let's look at the second scenario. That's way more fun, and I'm so sorry that the target is Ghent. I live in Ghent and I love Ghent. Okay, so this is nothing personal. This asteroid would be again 1 kilometer wide. It would go with a speed of 50 kilometers and going perpendicular to the surface. And it would be rich in iron. So what would happen? As you see the map, the red circle over there is not the area where it might fall. This is the final crater that would be created. So, for example, Zeeland is there as well, and other towns around. Even though if you would be in Brussels, you would suffer a lot. There would be so much ejecta falling down to Brussels. So therefore, I have looked at the calculations. What would people in Paris experience? So it gives you some kind of idea how massive this event would be. So ejecta would arrive in about 4 minutes. The thickness would be around 16 centimeters. That's a lot. Like seriously, coming ejecta from the air, that would be too much. Air blast would come in 15 minutes with maximum speed of 147 meters per second, also very, very high. There would be earthquakes. Many buildings might not survive this. Your furniture at your home would be turned down. And there is one big difference between this event and the first one. With this speed, 50 kilometers per second, what would happen would be after the impact that there would be a fireball created. It's just a ball of really, really hot vapors. And they create so much heat. The irradiation time would be around 8 minutes. And it would appear this, if you are in Paris and you would look towards Kent, you would see a huge, huge, huge ball, a fireball that would look that would appear on the sky 20 times bigger than the sun on the sky. What would happen would be that your clothes would start to burn. You would get serious burns on your skin. Newspapers, grass, trees immediately would start to be on fire. So this is truly very, very bad event if that happens. So that's what you wanted to hear. So I hope this was satisfying enough. And now let's continue to another topic. Don't worry, there will be some other questions for you, so you can again vote later on. Now we are going to look at our sun, if there are some possibilities that our own sun can endanger us. If you look at sun right now, it's cloudy right now, but if you look at sun with your sunglasses, you might feel that the sun is very, very calm. However, our sun is constantly radiating radiation and also sending plenty or flood of particles towards us in a form of solar wind, and sometimes the sun can even get really, really stormy, and it can sometimes even send towards us chunks of its own plasma. We call it coronal mass ejections. It can also accelerate surrounding particles, and they can reach really, really high energies and speeds. They can be also pretty dangerous. Of course, if all of this would hit Earth right away, that would be very, very bad. But our Earth does have a protection. The protection is in a form of the atmosphere. The atmosphere helps us to be protected from X-rays, gamma rays, and also our Earth has magnetic field. And the magnetic field acts like a shield against all these charged particles. It is pretty interesting, the whole topic of the phenomena of the interaction of sun and Earth. And we call this space weather phenomena. And just to show you one video, I really like this one. I hope you will enjoy it as well. Here you're going to see such explosion, as I said, that the sun sometimes can throw some chunks of plasma. So you're going to see it now in this video from Soho on 23rd January 2012. So where you see the white circle, there is the sun. It has to be hidden so we can see the surroundings around. What you have seen is a coronal mass ejection, so really huge eruption on sun. But then notice that there are these little dots right now, all these little dots. These are the energetic particles that they were accelerated and fell on the detector. I find it really fascinating. Okay, how to get back? Okay, here. So, all right, what is the deal? Can this endanger us? Well, the thing is, no. Space weather cannot wipe out the whole humanity. Don't worry about that. However, it can cause some problems. So, for example, if you happen to be in orbit, you know, ESA is now calling for astronauts. So, if you want to become an astronaut and you are up there, be careful, especially for the bad radiation like X-rays and gamma rays. Somebody would let you know that you have to go and hide. But also, if you have a satellite in orbit, they can be damaged from the charged particles, or mostly from the charged particles. If you're on the ground, you can be endangered as well. If you're in the aircraft, you can get some extra dose of radiation. Power grids are endangered. Even drilling companies can have problems to drill well because the magnetic field can be a little bit changed, or there will be some instabilities in it. So all of this is very important for everyday life. The space weather effects. These are truly important. You might not notice them, but all the people who provide services like navigation in your phone, they have to monitor or be informed about the space weather so they can work well. This is something we are trying to work in our institute. And yeah, if you are interested, definitely look at it. However, as I said, this will not endanger us fully, but our sun has another ace to draw, and it's the final ending stage of our sun, because our sun is going to die and it will be totally doomed for our civilization. But this will happen in many billion years. So what's happening right now? Sun is getting brighter and brighter. Our Earth will get warmer and warmer. And the critical point will be in 1 billion years when our atmosphere will dry out. The next development will be that there will be many processes in the core of our sun that they will produce much more energy, and our sun will expand. The reason why they will expand is that when the core produces so much energy, the sun has to somehow cool down, so it will expand. It's like you in summer when there's a heat wave. I hardly think when you are feeling hot that you would hug yourself, right? We all just stand and hope to cool down somehow. The same is with the stars. They expand to, let's say, cool down. What will happen in 6-7 billion years is that our sun will become nearly 100 times wider than it is right now. So if you would happen to be on Earth, that is impossible, you would see the sun covering nearly a third of the sky. It would be just beautiful, and the sun would be very, very red. So that would happen, and what would happen on the Earth would be that there would be so high temperatures that even the rock would melt. And it's because of the luminosity of the sun. The energy emitted per second would be nearly 2,000 times higher. So it would be impossible to live on Earth. Now, on this picture, you can see the final stage when the sun would throw the outer layers away and just the core would be seen. So what you're going to see, or what you're seeing in the presentation, is a real picture where a star that was similar like our sun just finished its life in full form. So don't worry, this will happen, but definitely not in our lifetimes. And now, I would like to ask you what you would like to hear about in this moment. Again, if I may ask you to go to WooClap, Pint of Science, and vote. Either you would like to hear about situation when space weather was nearly a cause of a Third World War, or you would like to learn a little bit more about space weather impact on animals. So let's give it a few seconds. And in a bit, we will look into the results. How is it going, Stan? People are voting? Yes, okay, so let's stop the vote. And it was the first topic, right? Okay, I see that the people are also excited about destroying the humanity, I think. Wonderful. So let's look at it. Voila. This happened in the spring 1967. In May, there were huge tensions between Egypt and Israel, and on 22nd of May, Egypt sent about 100,000 soldiers to Sinai. This was a huge thing that resulted even in a six-day war. At the same day, when the whole world was watching, and I just want to remind, at that time there was still Cold War between US and Soviet Union. At the same day, Soviet Union launched something into orbit. United States didn't know what. Few hours later, United States launched something as well into orbit, and Soviet Union didn't know what it was. So there were many tensions. Now we know that they were spy spacecraft. However, they didn't know. There was the big escalation. The relationship was very, very tense. The next day, something very odd happened. They noticed, US military, that the radio communication went weak, became weaker and weaker. It was hard to communicate with airplanes or aircraft in the air. And even the satellite communication went bad, the signal was delayed. And at one point, the radio communication even disappeared. And at that moment, there was a huge radio signal at a frequency of 440 megahertz. At that frequency, it was thought that nothing natural can emit. At that frequency, they tried to detect ballistic missiles coming to the United States. So all their warning system was based on detecting ballistic missiles on this frequency, and there was this huge signal. So that meant that probably there are some ballistic missiles coming to the US. So there were orders, bombers were in a takeoff position, in a runway positions, engines were on, but they had to stay on hold, because once you send bombers, it's pretty difficult to send them back. And also here the radio communication was already pretty lost. So they were waiting for Pentagon to decide if there are ballistic missiles coming, you have to act fast, right? However, there were some physicists who found out that maybe there is a chance that all of this is connected to space weather, to some events happening on the sun. Before, they didn't notice any signal on 440 megahertz before, but now in such a situation, they did. And they were very, very much confused. But looking at other points and other criteria, they found out that probably it was a space weather event, and they stopped the whole mission. Who knows what was happening in the Soviet Union, but probably the situation might have been very, very similar. So you see, space weather cannot wipe us out or kill us, but bad interpretation and bad use of technology can cause us to, not directly extinct, but definitely to be partly wiped out. So that was our space weather. And please keep your devices next to you, because we are going to vote again. And here we go, into interstellar overdrive. I would like you to vote. What would you like to know now? Supernovas and the dangers coming from supernovas, if explosion of a supernova can kill us or make us to go extinct, or if you want to learn something more about gamma ray bursts. So please vote again, and we'll look at it together in a bit. Okay, so either supernova explosions or gamma ray bursts. So let's say 5 seconds. Voila. Yeah, I see, Stan, you see some results, so let's stop voting. Number 2, gamma ray burst. Okay, you know that this is much more energetic event. I see that. Yeah, all right. Let's do that. Gamma ray burst. Again, we are going to the years of Cold War. In 1963, UK, US, and Soviet Union signed nuclear test ban treaty that limited testing of nuclear weapons. However, the United States was they didn't trust Soviet Union that they are not going to test nuclear weapons on the other side of the moon, for example. So they built telescope or detectors. They were sent into the orbit to see if there are any gamma rays. Gamma rays, just quickly to explain, gamma rays are very, very energetic. It's very energetic radiation. It's actually still photons, exactly, kind of the same photons that go to your eyes, but with way, way, way more energy, with much smaller wavelength. Okay, so this is really the most energetic radiation we can have. So they were trying to monitor if there are any such flashes of gamma rays, and they did detect some of these flashes. However, they didn't look like something coming from a nuclear weapon. Later on in other years, they detect more and more. Later in 1991, there was a Compton gamma ray observatory monitoring the whole sky and found out about 2,700 gamma ray bursts. And here comes the interesting fact. You see a similar map of the gamma ray burst on the sky. What you might notice is that they are very nicely spread out. If there is something that creates these gamma rays, it's coming from the solar system, it wouldn't be spread out evenly because Earth is not in the center of the solar system, as of course we know. So it would look differently. It might not come from the Milky Way, from our galaxy, because then all the sources would be in the plane of the galaxy. So it meant that they are coming from much farther places, from distant galaxies. So these sources of gamma rays must be incredible because they produce the most energetic radiation and coming from such far away places. Well, let's go directly to what it is. In 1997, it was found out what's the villain. I have to be honest, there are two different ways how you can create gamma ray burst. One of them, the less common, is that two neutron stars merge together. I'm not going to give much more details about it, definitely read about it. I would love to talk now about the most abundant source of gamma ray burst, and that's hypernova explosions. Hypernova explosions are, again, very fascinating. To have a star that explodes as hypernova, the star has to be really, really massive, at least 40 masses of our sun. Due to various processes in the core, happens that the core of the star starts to collapse and collapses into something that is completely strange, and it's called black hole. So if you hear anytime about a black hole, it is most of the black holes, stellar black holes, are created by collapse of a star core, but the star has to be very, very massive. So when this happens, that the core collapses, the surrounding materials, still the star, the outer envelopes, fall towards this black hole. But because the star spins, the material also spins and starts to spiral down towards the black hole. What happens is that this material creates a disk, and because of immense friction between the material, it heats up. So the disk is really, really shiny. It's heated up to immense temperatures. And what happens with a particle that it's very much heated up? It wants to escape. But there is one game changer, and it's magnetic field, because every star has some kind of magnetic field. And during this whole collapse of the center of the star and the material falling in, the magnetic field twists and creates something truly, truly unique. They create magnetic fields that enable the material from the disk to get out of the surroundings of the black hole in the form of two beams. Please don't be misunderstood. The material cannot escape from the black hole. We are now talking about the surroundings around the black hole. So if the material is in that disk, there is still a chance to escape, and it is in those two beams. Now, what happens is that these beams of charged particles go out and they hit the surrounding medium, creating plenty of reactions that later on create gamma rays and plenty of other radiation, but gamma rays really in an immense way. And these are actually the gamma ray bursts. Also, particles get accelerated to really high speeds, and they are all being nicely directed. And if this beam of gamma rays and energetic particles is directed to our Earth, then we are truly doomed. Let me explain what would happen if such a gamma ray burst is directed to our Earth. Let's talk about this beautiful picture here. This is a star at Carina that is about 100 solar masses, and this star might explode as supernova and create this gamma ray burst. But as you see from the picture, from the symmetry, this might miss our Earth. However, if such a beam would be directed to the Earth, and this is in the distance of 7,500 light years, what would happen? The X-rays and gamma rays would partly destroy the ozone layer. There would be a huge problem because the dangerous UV light from the sun would reach the Earth and attack or hit the base of the food chain, all the organisms sensitive on UV light. What would be burst would be the energetic particles that would arrive in a few hours. Because if you have an energetic particle that hits the Earth atmosphere, it creates a shell of secondary particles. And these particles are very dangerous to our skin, to our bodies, because they go directly to the cell and can destroy the DNA. If that would happen, the dose you would get would be 10 times higher than the lethal dose. So you can imagine that the whole civilization would be truly doomed. 5 minutes to go. So let's move on to the last topic. By the way, when I was talking about the extinction events, the one that happened 440 million years ago might have been triggered by gamma ray burst. There is such a hypothesis. We have a little bit more time, so let's go for the last topic. Please take your devices and let's get voted. Would you like me to talk about black holes and what would happen if a black hole comes closer to our Earth? Or would you like to know something about aliens destroying the humanity, anything surrounding this topic? Let me know, please. This is the final vote, so express yourself. Black holes or aliens? A few more seconds. I have a guess what people might vote for. I am right. Okay, so let's finish the voting. I knew it. Aliens. But I hope that the listeners, I hope you don't expect me to tell you that, yes, aliens are coming in 5 hours, because I cannot say that I can predict that, of course not. However, I'm very happy you've chosen this topic because I would like to say a few things. When we are talking about alien life, many people imagine immediately alien intelligent life, but this is not the whole life, just intelligent life. There's so much life that can be present, like viruses, bacteria, or more complicated organisms. So what I would like to say is think more broadly when you, for example, hear about Fermi paradox. Fermi paradox is there is so many galaxies in the universe, so many stars in each galaxy, hundreds of billions of stars in each galaxy. And each of the stars, like our sun, can have or do have planets. And some of them can be habitable. How is that possible? That there are no aliens around. Anyone who would contact us or anything would see that was created by aliens, how that is possible. So this is called Fermi paradox. In here, I would like to express some of my ideas, because again, this Fermi paradox talks about civilizations that use technology, but there can be life that didn't get to technology or don't have the reason to go to technology, and there is immense research in this topic. So it seems like there is no alien life. That's it. We have all the tools and we don't see anything, but this doesn't concern the immense work of astrobiologists, of people who search exoplanets, because there are possibilities how to find some signs of life. You have to take spectra for example, to take spectra of the star and its planet, then take spectra just of the star, and the planet is on the other side, and deduct them, and you can get the spectra only of the atmosphere of the planet and look for some gases or other signs of life. This is current research. It's amazing and it's ongoing. So don't be disappointed. There might be life in the universe. Another thing is we are still talking about aliens contacting us, but what we are doing, are we trying to send some messages out there? One would say, yes, there is a radio signals and so on, but honestly, the radio signals we produce are very, very weak. So even at the star that is a few light years away, you wouldn't get it. You wouldn't detect it, probably. Here on this huge table, you can see all the messages we have ever sent out there. You can see many numbers. These are the stars that were directed. You see the dates it was sent. But all these messages are pretty short. They can, yes, some of them can last for a few hours, but they were sent and it's done. It's not repeated. So we ourselves, we don't send messages frequently or regularly, but we expect the other civilizations to do it. So, as I need to get slowly to the end, one last thought I would like to share with you is that probably there's some kind of big filter. Maybe our civilization is truly just made it. We survived plenty of catastrophes coming from the universe, and therefore we reached for the technology. However, it's also there's a possibility that those civilizations that do get to use technology, and again, this is applicable for civilizations with technology. There might be others that didn't get to the technology or they don't want to, or any other reason. Maybe the civilizations that have technology, they maybe wipe out themselves. Maybe they change their climate so much that it's irreversible. Maybe they create so many weapons that at the end, at some point, they just destroy themselves or part of the civilization that they cannot use the technique or the technology again. So there are plenty of debates about it. And this leads me to the end of my presentation. And let's see on the first slide. So you see here, I clicked before in the left corner where there are all the mass extinctions. In the right corner over here, who you see here? People, right? Because there is another extinction that is happening right now. It's called the whole sun extinction, and it's caused by us, by people. As I said, there's always some kind of background extinction happening, but we see that when people started to be around, that the extinction rate became crazy, became really, really high, became 100 to 1,000 times higher than the background extinction rate. There are models that shows that the current rate of extinction is 10 to 100 times higher than in any of the previous mass extinctions. This is crazy. So, as I need to slowly stop, I just want to say that also with the nuclear weapons, we have created ourselves, and we are turning the climate into, we are changing it too much. In my view, the worst threat from the universe is us. We are the worst thing probably universe have ever created that can wipe us out. However, from all those dangers I have shown you today, those that are created by us, by humans, these are those we can do something about. We still can mitigate the consequences of climate change. We still can prevent nuclear extinction. So don't be scared from the universe or the events coming from the universe, but realize that the future is still in our hands. Thank you.
Well, thank you very much, Lenka. It was a very interesting talk, and we bounced from a lot of emotions, from the universe will kill us to no, the universe will not kill us to we will kill ourselves. I think we need some time to cope with that, but some people have been asking questions in the chat. So if you don't mind, I'm going to give you a few questions that people would like to know. And the first one is from To Fix This. I hope I pronounced that correctly. He or she, shouldn't assume gender, has read about SpaceX and their new satellites disrupting astronomical observations. Does it impact our ability to see asteroids or extreme space weather coming?
Oh, very nice question. Indeed, yes, they are ruining many astronomical observations, like the fact that you can see the satellites on the night sky. Some people might find it romantic, but astronomers are really absolutely not happy. However, the Asteroid Watch, the surveys, and other, for example, for the space weather, some of them are based in the orbit themselves, so they might not disturb some of the surveys that much. However, sending so many satellites, and especially the little ones, the cube satellites, creates so much trash in the orbit. There are even not many regulations. So actually, what their policy is that, all right, we are going to send as many CubeSats as possible. Some of them will not be functioning, but if we send a lot of them, some of them will be functioning. And they're just creating trash. Not just SpaceX, but also other companies will do, or they are preparing. There is even, you see, I'm very angry about this. There are even plans that there will be satellites sent out to create a meteor shower for you. So, for example, if you have a wedding and in the night you just want to have meteor showers, you would see these falling stars. These are not, of course, falling stars. These are just dust particles going through the atmosphere and creating these beautiful meteors. They can create it in the way that they send some dust in the orbit, and at a particular moment they just release it, and you see the beautiful meteor shower. But this creates so much trash, and there are no proper regulations. So this is a big problem, and it's necessary to work on this. Yeah.
I see some parallel between the universe and the kick scooters that are now everywhere in the cities that also are polluting and always in your way. A second question we got is from someone called Christine van Damme. I think I know who that is. I think we didn't organize a panel discussion, so our speakers are using the chat function to discuss with each other. And the question is, you gave some statistics about I think this had to do with the asteroids hitting the Earth. And are there plans for different statistics? Or is this impact kind of universal? And that was a pun.
Can you repeat again if there are any?
If these statistics, are they specific for Earth, or do they differ per planet?
Yes, so this one I was showing, this was for planet Earth, because it considers those asteroids that are near Earth or near the orbit of our Earth. So these are called NEOs, not like from Matrix, but near Earth objects. But of course, some asteroids can still hit other planets, but there are probably statistics like that, but they're not that popular, I guess. But yeah, but we observed many interesting events, like for example, the Shoemaker-Levy comet that exploded in the atmosphere of Jupiter. So yes, there are plenty of impacts happening on other planets as well.
Okay, great. I think we should round off now because we're almost out of time, and we want to have a quick break before 7:30 when we have another speaker. What I remember is that space weather will not kill us, but bad use of technology might. And coincidentally, our second talk will maybe be about that, how we're using bad technology, use technology to kill us, and the humans are getting killed themselves. That was also the message of your talk. We don't have a real audience here, so we don't have applause, but I'm assuming everybody is applauding behind their computers now. So thank you very much. It was a great talk.
Thank you very much. Thank you for listening.